Our next type of sequence is a geometric sequence. So a sequence is geometric if each term can be obtained by multiplying the previous term by a common ratio. And the letters you'll see in the equation u1 again, which is the first term, and r is a common ratio, and we can find the ratio by doing the u of n plus 1 divided by un. So what that means is you can use, say, u4 divided by u3, or u2 divided by u1, u10 divided by u9. And our formula for a geometric sequence is un equals u1 times by r to the power of n minus 1. So a couple of examples to show the different situations you might see with geometric sequences. So the first one, we have the sequence 16, 8, 4, 2, 1. Show that the sequence is geometric, find the general term, so find the formula, and then find the 10th term as a fraction. So for part A, show the sequence is geometric. So what I want to do here is show that r would equal 8 divided by 16, so that equals a half. Show that 4, and then do u3 divided by u2, so 4 divided by 8, which also equals a half. You can show with u4 divided by u3, so 2 divided by 4, and just showing that they all equal the same thing. So that shows it's a geometric sequence. B, find the general term. So we're just going to write into a formula. So un, our general formula is un equals u1 multiplied by r to the power of n minus 1. So it's still going to be un. Now u1 is our first number in the sequence, which is 16. And our r, we've just worked out before, is a half. So it's going to be 16 times a half to the power of n minus 1. So you can write it that way. You don't need to write the times symbol if you don't want to. You can just write 16 and then a half to the power of n minus 1. Now C, we want to find the 10th term. So we're finding u10, which will equal 16 multiplied by a half to the power of 10 minus 1, which is 16 times by a half to the power of 9. Put that in your calculator and you will get 1 over 32. You can do this without a calculator as well, so what this would be is 16 times 1 to the power of 9 over 2 to the power of 9. 16 we can rewrite as 2 to the power of 4, so this ends up being 2 to the power of 4 times 1 over 2 to the power of 9, which equals 1 over index law, so it'll be 2 to the power of 5, which is 1 over 32. Example 2, similar to what we did with arithmetic sequences. So we've got k minus 1, k plus 2, and 3k are consecutive terms. Find the possible values of k. So to find r, we can find two equations for r. So we can have the second term divided by the first term equals r, and r would also equal the third term divided by the second term. Now because these both equal r, we can make them equal each other. So we'll have k plus 2 over k minus 1 equals 3k over k plus 2. And now we can just solve this using our beautiful algebraic fraction knowledge. So we'll have k plus 2 cross multiply the denominators, and then just expand and rearrange. And what you'll notice is going to end up as a quadratic. So we'll take everything to the one side. So we'll get 2k squared minus 7k minus 4. And then you want to solve this. So you can either do factorization, you can do completing the square, quadratic formula. And when you solve this, whichever way you choose to solve it, you will find that k will equal 4 or negative a half. And for this, you see in the question it says find the possible values of k. That's kind of a little hint that there possibly could be more than one answer, and there is in this situation. You could have 4 or negative a half. And example 3, a geometric sequence has u2 equals negative 5 and u5 equals 40. Find its general term. So when it says find its general term, it means find its equation, find the formula for this sequence. So once again, we're going to kind of have some simultaneous equation idea. So we know that u2 equals negative 5, and then u2 would also equal u1 multiplied by r to the power of 2 minus 1. And so u2 is negative 5, so negative 5 equals u1 multiplied by r to the power of 1. And then we know that u5 equals 40, and u5 would equal u1 multiplied by r to the power of 5 minus 1. So 40 equals u1r to the power of 4. Now when we have geometric sequences and we're working these ones out, what we actually do is we divide them by each other. Best to put the one with the highest power on top, so it would be u1r4 equals 40, and divide each side by the other one, so u1r equals negative 5. Now the u1s will cancel, and we'll end up with r4 over r, which is r cubed, equals 40 divided by negative 5, which is negative 8. And solve that, so it'd be r equals the cube root of negative 8, which equals negative 2. So in this situation, r is negative 2. And then from there, we can sub in and find what u1 is. So I'm going to use the u2 term, so negative 5 equals u1 times by r. And so it'd be negative 5 equals u1 times by negative 2, because that's our r. Divide the negative 2, so we'll get 5 on 2 equals u1. And then we can put that in to find our formula. So the un would equal u1, 5 on 2, multiplied by r to the power of n minus 1.